So me and Mike do the roll in the next 5 or 6 minutes, okay? Now, here's what we're going to do first and foremost, all right? Does everybody remember a squared minus b squared? Difference of two squares. Go on, so tell me what the answer for that would be. A plus b and minus b, right? Now, take question 49 as an example. I can make these questions crazy by doing any of these choices I want. What happens if I replace a with x squared and I replace b with, for argument's sake, y squared? What happens to the question then? It becomes x squared here minus y squared squared. And the answer to that would be x squared plus y squared. And then, now, here's the kicker, okay? Do you guys remember your rules of indices? Okay, give me a second. I'm just going to go underneath. I'm now creating a new question to explain the rules of indices really quickly. Is that okay? Yeah, I'll show you now, all right? 2 to the power 3 multiplied by 2 to the power 4. Anybody know the answer? Is 2 to the power 7. What we're essentially saying here is that we're saying 2 by 2 by 2, 3 of them, isn't there? And then we're also saying 2 by 2, there's 4 of them here. How many in the line is there in total then? 7. So, long story short, when you see two big numbers, see the two big numbers, and you see the two powers, you add them. Is that all right? Now, once again, what I love doing is I love creating two questions that look alike, but they have different answers. Okay? So here's the next one. Need you clued in as well, all right? Anybody know the answer to this one? It's 2 to the power 12. And let me explain why. It's technically 2 to the power 3 how many times? There's 4 of them. And then if we use the addition rule, what happens when we add them all together? 12. So long story short, what I want you guys to memorize off by heart is the following. One big number and two powers means you're multiplying. Two big numbers and two powers, generally speaking, you're adding. Okay? Now, one last thing, just to make sure we don't get everything confused. How would you do this one? Yeah. Nope. You do that for multiplication. So you add the powers for multiplication. You can't is the answer. If it's not being multiplied, huh? You can't add. Yeah. Sorry, there's different as apples and oranges from each other. So you'd literally just have to multiply it out and go. That's 8. That's 16. The answer is 24. You can't do anything with it. And I can't even express 24 as a power 2. Can anybody explain why I can't express 24 as a power 2? Let's start off. What's 2 to the power 0? Oh, okay. It's all right. It's all right. We'll get there. All right. I'll start off here. 2 to the power 1. 2. 2 to the power 2. 4. 2 to the power 3. 8. And then everybody says 2 to the power 4. 16. 2 to the power 5. Do you know 24 is not on that list? See why I went from 16 to 32? So we wouldn't have been able to do anything with the 24 anyway. Now, just while we're here, and this is quite important, it gets halved every time, doesn't it? See why 32 turns into 16, 16 turns into 8, 8 turns into 4. Predict what 2 to the power 0 is. 1. Any number to the power 0 is 1. Now you might go, I don't understand that. Well, neither do I, all right? And I'll explain why. Yeah, I know some of you are laughing at me, all right? Do you understand why C comes after B in the alphabet? Do you understand it though? Somebody made it up, yeah? Same system. This makes no sense on its own, but when you apply it to a different system, it eventually makes sense. But in the same way, when you're learning how to spell, you don't ask why C comes after B. They just say it just does. And this is one of these cases. they made up a system where any number to the power 0 is always 1. If I ask you 200 to the power 0, 1. A million to the power 0, 1. All right. Now, here's where things get unusual. What do you think 2 to the power minus 1 is? Think about what we did all the way here. Half the, half the, half the. A half. 2 to the power minus 2. Now you got it. And that's how powers work. Yes. What? No, the Greeks did. And the Egyptians. Well, they created a system to communicate it. Is that more accurate? Last thing here. If I gave you 2 to the power minus 3, all you do is put a 1 on top and you put 2 to the power 3 on the bottom. And what's 2 to the power 3? An 8. That was the next one in the list, wasn't it? Half a quarter to get it. An 8. Yes. Sorry, that's a poorly drawn 5. Yeah. Yes. No. So you just asked me about 20 to the power minus 2, is it? Okay, just give me a sec. We're all good. Believe it or not, it's c to the power 2 and c to the power minus 2. It's always the upside down version. So if I ask you 2 to the power minus 5, what do you think the answer is? Look at 2 to the power 5. What's 2 to the power 5? So what do you think 2 to the power minus 5 is? 1 over 3, 2. It's always the opposite of what the positive one would be. Is that okay? Always has to be a fraction. And you notice that it never goes negative. It just stays as positive fractions and just keeps getting smaller and smaller. Is that right? Is that the first time you came across stuff like that? No. Okay. Okay. Now, yes. Now, what we're going to do, this, guys, is can you explain to me what I just told you a second ago? One big number, 2 small numbers. Add or multiply? Multiply. So what's that? X to the power of 4. This one? Y to the power of 4. And now we have our answer for question 49, don't we? Now, here's what I'm going to try with you guys now, right? And this is, now, believe it or not, do you think this is fully factorized? Sorry, 2 questions. I'll slow down. Question 1. Lads, say something. If I multiply that back out, will I get the original answer? What's x2 by x2? Yeah. x2 by y2 minus x2 y2. y2 by x2. 2 of them cancel, don't they? And then y2 by minus y2. Yeah, so it works. Okay. Now, since I did that one for you guys, what I might suggest is we might get you guys to try this one out. Oh, sorry, still haven't got this right. Anyway, looking at the back of the book, probably tell me I did it wrong. Can anybody tell me what can I do with this part here? Into what? It is. So there's 3 brackets as my answer, isn't it? Okay. So once again, will you take down that I did number 49? Guys, would you try question 50 now on your own? I'm just going to take the old roll. Shh. All right, gents, okay? Now, the real problem is, okay, so do you guys remember me doing this in yesterday's class where I wrote down Kenny squared minus Mark squared? And what did I say the answer was? Kenny plus Mark and then Kenny minus Mark. Is that okay? Remember me doing that? Now, yeah, exactly. Now, instead of Kenny and Mark, I'm doing question 50 right now. What can I put in there instead? Now, see the 9. I identified the 9 as a square number. So I changed that to 3 squared. Now I have something squared minus something squared. That to me means I definitely use that a squared minus b squared formula because it's something squared minus something squared. Are you with me so far? All right. And then we go x minus y in here, 3 in there, And then what happens when I open these two brackets up? Instead of a, I have what? Instead of a, we have and y. We have x minus y. Instead of b, 3. And then over the other side, yeah. And then, yeah, it is indeed. Okay. Question. Yeah. Okay, guys. Can you try 47 on your own now? So 47 on your own. Now, so guys, remind me to talk about that in a second, okay? So guys, I was asking you guys to x4 minus 25, okay? Now, the first thing, you're probably wondering, how do I even know that this is a difference of two squares? Like, how do I even know that? Okay, I'll explain why. There's two parts. There's this part here, and then there's this part here. There's two parts, and there's one minus in between both of them. Now, the only problem is neither one of them are squared right at this point in time, are they? So what can I change x4 into? Yeah, x squared could be squared. And what can I change the 25 into? Yeah. And now replacing x with a with x squared, what can I say? And is that okay with you guys? You can leave it like that because 5 isn't a square number, is it? So I can't do the difference of two squares again. So we're safe there. Okay. Now, somebody asked me earlier, you have certain formulas. The first formula is a cubed. Sorry, the first formula is a squared minus b squared, and that's listed above, isn't it? The second formula is a cubed plus b cubed. We used that earlier today, didn't we? And the other formula is a cubed minus b cubed. And we also used that in today's class. There is no formula for a squared plus b squared. That formula doesn't exist, and it just stays exactly the same way. Is that right? So if I was to ask you this question, if I was to ask you the same question as question 47, if I was to ask you that question like this, you can't do anything. No, it's just stuck there. Okay. Now, next thing. Oh, it's gonna be fun. All right. All right. So, uh, okay. Yeah. All right. Take a standard quadratic equation like this: x squared minus 2x. Actually, no, I don't want to do that one. X squared minus 4x plus 4. Everybody see that? Okay. Now, would everybody agree? Everybody knows how to factorize this, right? It's x minus 2 and x minus 2. Is everybody cool with that? Now, what happens if I change this and I wrote it like this instead? X squared y squared minus 4xy minus 4. Does everybody see that the structure is the same? What do I mean by the structure? It's still something squared, isn't it? It's xy to be squared. And then it's 4 times xy. And then there's a 4 at the end. You see the way it's exactly the same structure as the one on the left, except it has an extra y tossed in. Is that all right with you guys? Now, how would you do this question then? What would the answer be? Instead of having x, what do you have? So what do you think the answer for that question would be? Xy minus 2 and xy minus 2. All right, so what I just showed you there is very close to what you need to do for question 48. You just write down question 48 anyway on your list, right? I won't be doing 48 now because I'm running out of time. Okay. Now, the next one we're also going to do is question 51. So if you're wondering how to do question 48 later, I left a tip plus that last thing I did is how you do it. Okay. Now take this one. Once again, I'm going to make up a quadratic equation for myself. Right? I'm going to make up x squared minus same thing as last time. Are we cool with that? What do we know the answer is again? We know it's x minus 2 and... Okay. Now, what happens if I add on a y here? I just manipulate it slightly. And I ask you to factorize that instead. What would the answer be? What do you want me to put here? I'll put a y there, and I'll put a... And if you multiply this out, what will you get? You'll get all that back out again. So when you're doing question 51, ignore that the y even exists. Just get rid of the y, factorize it normally, and then slot the y's back in at the end. Does that make sense? So tonight you're going to be doing 48, you're going to be doing 51, 52, take out the a. I'll start you off there. That's a hint for 52. For 54, I want you to take out AB2, and you'll be left with b cubed minus 1. There's another hint for that one. Okay. Okay. I might put up all the solutions online soon, you know that, just so you can help yourselves as well. You know, the book gives out a solution as well. I'll log that into Google Classroom as well, just so you can help yourself. Don't just copy it mindlessly either. You have to know what you're doing. So for tonight, we're going to go 44, 45, 46, 48, 51, 52, 54, and 55. Okay.